Mental Math Challenge. This is one in a series of mental math practice games. This game came out of a need to add interest and purpose to teaching the distributive property. When I used to use it, I scheduled time to play it every day, the last few minutes of class, for the time we were studying the distributive property, and just before we tested over the distributive property, and then throughout the year, just as practice. When I was young in my math teaching career, I didn't realize that there were purposes beyond algebra for the distributive property, like mental math. So I would teach the A times B and A times C and all of that, but I didn't realize there was a purpose beyond that. And once I realized that, then I started using it to teach mental math. I would actually teach the mental math part before I did the algebra part because it made so much more sense. The algebra made more sense once you saw it used with mental math. So there's one slight change. So I changed it from A times B plus C to just A times BC, not meaning multiplication between the B and C. A times BC is something like 3 times 21, where the 2 in the tens place and the 1 in the ones place. And I wanted kids to see the difference between the tens place and the ones place. So then it becomes A times B plus C, meaning that 3 times 20 plus 1. And you have to make sure that your students are writing 20 plus 1, not 2 times 1. Because if they just do 2 times 3, then it's going to get 6 plus 3, which is going to be 9. And so they need to see that that place value for the 2 matters. And then you have the A times B plus A times C part, which becomes 3 times 20 plus 3 times 1. And then the rest of that is just simplifying. 3 20s is 60, 3 1s is 3. And then you add that to get 63. I had the students write that form in their notes. And then on another piece of paper, I had them practice that form with different numbers. So like 4 times 42. And I had them write every step, even though you can do most of it in your head. And that's what we're going to get to with the challenge. I wanted every student to see what was happening, because sometimes you'll have kids that act like they know what's happening, but they really don't. So when they see it and they've written it several times, they start to get it. Now I did start with numbers that are less than 5, because during the adding step, I wanted them not to have to carry, because carrying with mental math makes it a little bit more complicated. Once they got the format down, then we made things a little bit more complicated. So this is the next level. So once they get used to the form, I start adding numbers or making problems with numbers that are going to have carrying in the addition step. So like 7 times 64, you can see down there that 7 times 60, and this brings in a conversation about multiplying by numbers that are multiples of 10. 7 times 6 is 42, so 7 times 60 is 420. You just put a 0 on the end. It's a great way to enforce that skill. And then 7 times 4 is just 28, because 4 is in the ones place. Here is where you have to add the numbers that are in the tens place. There's never going to be any number that adds to the ones, because it's going to always be a 0 there, because you're multiplying by a multiple of 10. And then sometimes you'll change the hundreds place, but it depends on if the tens place carries. In this case, you have 28 and 20. So in the earlier one, it was just a single digit number that you are adding to the number that had the 0 in the tens place. So there wasn't any combining of the tens place. Here you have a 2 in the tens place on the 420 and a 2 in the tens place on the 28. So here's where I had this conversation about how places add to the same places. The ones place adds to the ones place, the tens place adds to the tens place, so on and so forth. And I always left it side by side and not stacked, because with mental math, you want them to be able to understand the concept of putting it together and not just mentally go through the algorithm of adding it and carrying a 1. So if you see kids writing in the air, that's not actually mental math. That's actually paper pencil. They're just imagining that they're doing it. And there's a level you can go that's much more efficient and beyond that, where they understand that 20 plus 20 is 40. So 420 plus 28 is going to be 448. And they combine the place values. Once you've practiced that 4 or 5 times, then you start practicing this process, but skip writing down one of the steps. The first step I always skip is the B plus C step, because that's pretty easy to understand that 2 is 20 and 1 is 1 once they see it several times. I do, however, have them do these arrows so they can remember that they're doing 5 times 60. And when I have them describe to me what they're doing, I don't have them say 5 times 6, or I don't allow them to say 5 times 6. I have them say 5 times 60 and 5 times 4, because then I remember that that is actually not 6, but it is 60. And then you have them practice that 4 or 5 times, and you leave out another step. The addition step is by far the most difficult step, so we'd show them several different ways to do it without stacking and carrying. In this case, we would underline our tens place and see that 6 and 2 is 8, and then I'd ask him, is that going to carry? No. Well, then there's nothing to add to the 500, so it's going to be 500 something. Then I'd say, is there anything that's going to add to the 4, to the ones place? I point out that there's a 0 in the ones place of the 560. So no, there's never going to be anything that adds to the ones place in these problems, just the tens place. And so then I show them how to add the tens place. There's another way to do this one. You could think of that as 560 or 56 plus 2. Those are the 2 steps then that we practice over and over, way more than 4 or 5 times. And then as they start to get used to it and start to build patterns and see the way things work in conceptually, they're able to expand it. One of the ways I expand it is by using larger and larger numbers, such as 11 and 68. So they would have to do 11 times 60 and 11 times 8, giving them 660 plus 88. By now, they're noticing that nothing is going to add to the 8, so it's just going to be an 8 in the ones place. And then 6 plus 8 is in the tens place, and 6 plus 8 is 14. So there's going to be a 4 in the ones place, and 1 more than 6 in the hundreds place, because they have to carry that 1. But I encourage them to try to not write it down. At the beginning, when they're first learning this, I let them write down the addition step and some of the carrying. I push them towards the direction of doing most of it in their head. And most kids need to be pushed in that direction. They don't think that they can. And it is hard at first, but the more that you do it, the better you get at it. I do practice this a lot, and I allow them to write the addition step for most of that practice. And then I tell them, as you get better, try leaving the addition step out. Try doing it all in your head. Remember, your ultimate goal is for them to be able to do all of it in their head, because that's going to be the fastest way for the competition. So you want to gradually leave off steps until it's just you say 3 times 21, they think for a minute, and then they say 63. The Mental Math Challenge practices these skills: mental multiplication and addition by place value, because you're also going to mentally add. It also practices thinking under pressure, because it pits 2 people, sometimes 4, against each other. And there's a lot of pressure in that, and it teaches kids how to calm their own nervous system and focus on the task at hand. It also teaches the skills of losing and winning, because as we know, and as I've talked about, those skills are necessary in life. You need to know how to lose and how to come back from it, and how to win and how to not let it go to your head. One of the things I used to do when I did games club and we would play different sorts of board games after school, I would require the students start out each game with a handshake and, good luck or wishing them success in their game. And then at the end, both kids shook hands and had to say something that the other person did that they thought was good. Like, even if they won, they had to say, wow, you really almost got me there. That one move you did was excellent, and I had to come back from that. So even the winner had to find something good in the person who lost, and the person who lost had to see what was good about the person who won. That took some practice, but it teaches them also to review their own and how to learn from other people's wins. Here's what you need to play the game. I usually did 2 to 4 players depending on the situation that we were in, whether it was whole class or whether they were playing on their own. And then you can get a deck of playing cards and remove all the face cards, or you can use a deck of Uno cards. And the reason I like Uno cards is because they're very clear as to what the number is, and there's a lot of each number. So in a deck of cards, there's only 4 of each number. And this is an older style Uno deck, and there's a lot of them in there. You also can use like a 10-sided dice, 2 or 3 10-sided dice that you can use. And then what that's used for is to choose the numbers that the students will be mentally multiplying. I allow the students to have a paper and a pencil available, but they can only pick it up and use it if 30 seconds has gone by and still nobody has answered. So I want them to try and do it in their head mentally. So in order to get them to depend on their mental math skills, they have to have that crutch of writing it down taken away. And so after 30 seconds, and I might have changed it to 60 seconds depending on how much they would wait for it, I would allow them to write down one step on there. And then 30 seconds later, they could write down another step. And 30 seconds later, they could write down another step. That way, again, it pushes them into doing the mental work to solve the problem. The object of the game is to be the first to shout out the correct answer to a multi-digit multiplication problem, and always had various prizes that went along with this. So the rules for playing are simple. On a video screen in front of the class, or on the table between 2 players. So in front of the class, there would usually be 3 or 4 players, but if it's just 2 people, then it's just on the table between them. Choose 3 or 4 cards to be placed in the formation of A times and then a 3-digit number or a 2-digit number. I always started with a 2-digit number. The A card is not turned over until everyone is ready. Once everyone is ready, you reveal the A card, and whoever says the correct answer wins. So I'd be like, all right, is everybody ready? 3, 2, 1, go. And I would flip the A card over, and then they would, whatever answers they shouted next were allowed. If an incorrect answer was given, I would simply say no, and all the students would continue until the correct answer was given. They are allowed to say another answer until they are correct. You can modify that if students are just guessing answers over and over again and guess fairly quickly, and say that they are allowed 1 guess, and then somebody else has to give an answer before they're allowed to guess again. Once a correct answer is given, the winner stays where they're at, and the loser or losers, depending on if you're playing with 2 players or more, they take their seat and they switch out with other people to challenge the winner. And then you keep track with how many times each person has won. As soon as the winner loses 1 round, then they go back to their seat. So each time you have a round, you're going to have a different amount of people that have a run of winning or a winning streak. Keep track of that, because whoever has the most wins is the winner. So in an Uno deck, you separate out the word cards and keep just the number cards. Then you choose, if you're doing a 1-digit times a 3-digit, then you choose 4 cards. If you're I always start out just choosing 3 cards and doing a 1-digit times a 2-digit. Then as the teacher, you have to decide the arrangement. Are you going to do 2 times 96, or 9 times 26, or 6 times 92? But as the teacher, I would choose that arrangement before I revealed it. So I would have the screen on the TV in the front so that it was hiding what I was doing. I would make the arrangement, and then I would flip the A card upside down and turn the screen back on. Then I would say 3, 2, 1, go, and flip that A card over, and then they would start giving their answers or start calculating in their heads. Once you flip over that first card, the one that you're multiplying with, Then you just stand back. But I always had a calculator in which I had already calculated the answer, or a piece of paper if I had chosen several, and I had the answers written down on. Because once the kids get really good at this, sometimes they can calculate it faster than you can type it in on a calculator. Here are some things you might want to consider. Start with numbers that are not going to have any carrying in the addition step. So you might want to choose your numbers in advance. Many students write out the addition, but they don't write the calculation. So I allowed this after 30 seconds if no one had answered yet. So example, they might write 345 plus 45. Actually, it would be 340 plus 45. And then they would answer without writing any further. Most of the time, they just needed to see 340 plus 45. And then they could say it. I did give bonus points for students who could do this without writing anything down. And the bonus points really depends on how you're keeping score. While playing this, I eventually developed a tier system. So that level 1 was all numbers that are 5 or less, like 3 times 45. And then level 2 were all numbers 7 or less, like 7 times 65. Level 3, you do 11 or 12 times a 2-digit number of any digits from 0 to 9. Level 4, a 1-digit times a 3-digit. Level 5, 11 or 12 times a 3-digit number. Each level has an increasing point value for wins, or you could do a bracket system with increasing difficulty for each round. If you do this as a big competition, which I loved to do in my class, make the prizes something really cool. Something like homework passes, or we used to have a concession stand, so I would give the students a concession stand pass, and they could go to the concession stand during my class. Or I would give them a drop my lowest score pass, or something else, just make it up. Something that's really cool that the students are going to want, and something that's not given real often, so it's a rare prize, which makes it even more valuable. Thanks for watching, and have a fun time in your math class.